Hello everyone, my name is Sinn. I'm the founder of D-Cubed, and today I want to share some of our ideas on a path to commercially off-the-shelf deployable structures and how they can pave the way to advanced Earth observation Nanosat missions. So if you look at rocket launches, it still takes 95% of the energy, of the mass, of the volume to bring the other 5%, the payload, into space. So with the advances in small satellites and nanosatellites with their shoebox size, they can use quite nicely the space that's available under the fairing. But often the missions are limited by these form factors, so that's why structures that are bigger in space are needed. So here comes our solution. So we built structures that are small on Earth and then are getting big in space, so-called deployable structures and folding structures. Our idea is to make them completely commercially off the shelf, so they are quite cheap and readily available. And our idea is to make them completely in Europe, so there's no export regulation, and they can be used in a lot of missions rather quickly. So our technology is first we go for a trigger. So you can think of a deployable structure like an umbrella. First, you need a switch that is triggering the unfolding of the deployable umbrella, and then you can go into the umbrella, the deployable itself. So we started first with the pin puller and release nut that are the triggers. Here we developed these two products. They are used for triggering deployable structures, triggering the ejection of cube satellites from the CubeSat deployers, but also stage separation and also some planetary missions. And then with this enabling technology, we can build on our real expertise on deployable structure that unfolds when it is in space. And here we're thinking of various different structures. So it could be one would be a deployable antenna that can bring down data, then deployable solar arrays to have more power, deployable radiators to have more to get the heat away from the spacecraft, and also sails that can be used for deorbiting, for propulsion, but also for covering for sun shields or so. That brings me now to these different points of application where we can really help you as a satellite, as an application developer in figuring out what deployable structure is best for you, because you need deployable solar arrays, because most of these advanced mission, they need more power that is available right now. So you need to have bigger surfaces for bringing communication data down, or for electric propulsion. Then of course it's deployable antennas that can be used for imaging, like radar images, or even going to modeling biomass. And that's why you need deployable antennas. Then the other thing is deployable surfaces that can be used for shielding something, for example, for covering parts of the Earth, or for using it as a drag sail. Or then a big application is also for communication antennas, because you can collect a lot of data with these nanosat constellations, but what helps you with the data if the data is up on the satellite? So you need to have some way to bring it down. And if in each of these areas there can be standardized products, this will drive greatly the price of these systems. So the idea behind this presentation is more to start a conversation with you, to really see where are the application cases for such a deployable structure, because we know it from a structural point of view, we can make it big, but we need also your help to really work with you on applications that you need these deployable structures for. And with that, I finish my presentation, and I hope you reach out to us and let us know what deployables can do for you. Thank you.